This is Geometry, Lesson 5.3a. We're going to talk about bisectors and triangles. So there's two parts to this objective that students will be able to identify properties of perpendicular bisectors and properties of angle bisectors. This video will focus on the properties of perpendicular bisectors only. Alright, so here's just a refresher on some of our vocabulary words and some new ones. So concurrent lines is going to be a new topic we're going to cover over the next 2 days. They are three or more lines that intersect at exactly one point. Okay, so we talk about two lines intersect and cross, but this is three lines intercrossing at the same spot. Point of concurrency is that specific point where three or more lines intersect or are concurrent. We've been talking a lot about perpendicular bisectors. The perpendicular bisector of a segment is a line segment or array that is perpendicular to the segment at its midpoint. So today's going to use that topic and talk about actually how perpendicular bisectors are concurrent in a triangle. So that leads us to our very first theorem called concurrency of perpendicular bisector theorems. It says the perpendicular bisectors of the sides of a triangle are concurrent at a point that is equidistant from the vertices. So we take that apart in this diagram. These red lines that you have, XP, YP, and ZP, those are our perpendicular bisectors. It says that right here as well. Remember, they cut a side in half and make a 90-degree angle with it. And then that point of intersection where they meet is point P. That's the point of concurrency. It's where they're concurrent, where they all cross. And there's three more lines that are also formed where you can go and you can connect the vertices to that point of concurrency. And when that happens, those blue lines are actually all congruent. And so that's what it says right there. When they say, that's what it means when they say that perpendicular bisectors are concurrent at a point equidistant from the vertices, meaning that center of that triangle is the same distance from all 3 points. And so this point has a name. We're going to talk about that next, and it has some other properties as well. So the point of concurrency of the perpendicular bisectors is called the circumcenter of the triangle. We call it that because the circumcenter is equidistant from the vertices. So if you use it as the center, and these lines from that circumcenter to the vertices as radii, you can what we call circumscribe a circle about the triangle. So you can draw a circle around the triangle, and it's only going to touch this triangle and the 3 vertices of it. Okay, so that's the circumcenter. Now, depending on what type of triangle that you have set up, the circumcenter can be in different locations. So here's the different locations it can be in. It can be inside, outside, or on the triangle. So if you have an acute triangle, meaning the 3 vertices are all less than 90 degrees, so those 3 vertices are, it's always going to be inside the triangle. If you have a right triangle, your circumcenter is actually going to occur on the hypotenuse of your right triangle, so it's going to be on it. And if you have an obtuse triangle, those perpendicular bisectors are going to cross outside the triangle out there. So if it's acute, inside, if it's right, on, and if it's obtuse, that point will happen outside. So next we're going to talk about how do we actually find that point. Now it can be a tricky point to find, so what we really focus on is finding it in the coordinate plane because it's a little bit easier to do that work. So we have 3 problems where we're going to do this. The first one, it says find the circumcenter of the triangle. And so the circumcenter is formed by the perpendicular bisectors. So this is where you got to remember some of your prior knowledge from back in chapter 3 and some of the other chapters. So I would focus on the bisector first. We're going to have to bisect these segments or cut them in half, which means we're going to have to find their midpoints. Now the nice thing about many of these being in the coordinate plane is it's kind of easy to find their midpoints. Often you can count them, especially when you have a horizontal line like this one here or a vertical line like that one there. So what we can do is we can count the length of these sides. So on the bottom it's 1, 2, 3, 4, 5 units long. And so we want to think about if it's 5 units long, what's half of that? So we take 5, we divide it by 2, and we get 2.5. And when we do that, we can count 2.5 units from either endpoint, and we'll find that midpoint. So I'm going to go over 1, 2.5 right here, and I found a midpoint. Now I'm going to go do the same thing over here on this vertical line because it's easy to find that midpoint there as well. That is 2 units long, so I'm going to take 2 divided by 2. That gets me 1. So if I move 1 unit up or down, I get that midpoint here. So now I have my midpoint, so I can bisect those segments. Now I just have to focus on the perpendicular aspect. So remember, this is where these horizontal and vertical lines are your friends, because perpendicular to every horizontal line, so this one perpendicular to a line like this one here, oops, this one here, is a vertical line. So all I'm going to do is I'm going to trace that vertical line that goes through that midpoint. And perpendicular to every horizontal line, every vertical line like this one here, is a horizontal line. So I'm going to trace a horizontal line through that point. And where those two cross is my circumcenter. Now, I can take the time to do all 3 sides, to find the midpoint of all 3 sides, and then to find that perpendicular line through it, but you really only need to do this with 2 sides to construct those perpendicular bisectors. So now I just have to count the ordered pair for that point, and I have my circumcenter. So I go over 1, 2, 3.5 from the origin, and then I went up 1, 2, and I have my midpoint, or my circumcenter. So now I can do the same type of thing over here. Some of these lines are easier than others. So if I take a look at this, I look for a horizontal or a vertical line to start with, and I see this horizontal line on the bottom. So I'm going to count how long this is. It's 1, 2, 3, 4, 5, 6. Take 6 and cut it in half, and I get 3. So I want to go 3 units along, 1, 2, 3, and this gets me a midpoint. Now notice that this is a horizontal line, and so the perpendicular line to it will be vertical, so I can just trace that vertical line through. Now I want to move on to another side, and this is where sometimes these triangles can get a little bit tricky. If I look at these, these other sides, they're not horizontal or vertical lines, but you still might be able to find the midpoint just by kind of paying attention to them. If you notice, this one has a slope of up 1 over 1. Over here on the left, it goes up 3 over 3, which simplifies to 1 over 1. And you can see that it's going through those boxes the exact same. It might give you an idea how to find the midpoint. If you still can't find it that way, you can use your midpoint formula. That's your y2 plus y1 over 2 and x2 plus x1 over 2. So it's the average of your x's and the average of your y's. So if you can find the ordered pairs of those ends and average them together, you can get your midpoint. So I'm just going to find those endpoints to help me out. I've got 1, 2, negative 3, negative 2, and I've got 0, 1. So now if I just average those together, I go negative 3 plus 0, it's negative 3, cut it in half, and I get negative 1.5 for my midpoint. And then I go 1 plus negative 2 is a negative 1, cut that in half, and I get negative 0.5. So that's my midpoint. I go find that ordered pair, start at my origin. I go over negative 1.5, down negative 0.5, right there. Now, we found the midpoint. We used some chapter 1 knowledge to find it. The next thing that we have to do is find that perpendicular line. And so here's where we're going to use some of our chapter 3 knowledge. When you find a perpendicular slope, it is the opposite reciprocal slope of the one you already have. So what we want to do is actually take this red line and count the slope of it, which we kind of did already. We saw it went up 3 over 3, so the slope would be 3 over 3, which becomes 1. And now you want to think about, okay, 1 is the same as 1 over 1, and you want to do the opposite reciprocal slope of that. So opposite says if it's positive, make it negative. If it's negative, make it positive. So we make it negative. Reciprocal says flip it. And when you flip 1 over 1, you still get 1 over 1. So now I have a slope of negative 1 over 1. And so from this ordered pair, I'm going to count that. Now it's a little bit weird because you're having to kind of count in the middle spaces, but it should work out okay still. So we go down 1 over 1, down 1 over 1, and it's going to look something like this. You might notice that, oh, it crosses already on that midpoint of that base side, and that's actually because if we were to do if we were to check the slopes of these two red sides, we would notice that they were perpendicular and that this right here was a right angle, meaning we have a right triangle and the circumcenter is on that hypotenuse. So we just need the ordered pair for that green dot now. This will be our final answer. This problem got a little messy, sorry about that. We go check that ordered pair. It hasn't moved left or right at all, and it moved down 2. Alright, so we're going to have more of those left problems that are a little bit more straightforward at times, but we will do some of these where we have slanted sides as well. So we're going to try, this one says, what are the coordinates of the circumcenter of a triangle with vertices at 0, 6, 0, 0, and 4, 0. So we'll start by graphing those points. P's at 0, 6, that's at 1, 2, 3, 4, 5, 6. I like to label my points as I go so I can refer to them a little bit better. I would recommend that for you as well. So we have our triangle POS. And we're going to construct the perpendicular bisectors of this one. So I actually want you guys to try this one on your own. So pause the video. Remember, it's easy to find those perpendicular bisectors of horizontal or vertical sides. If you need a refresher, rewind the video and go check that first one. I don't have mine done yet, but I did get those midpoints on there by counting those side lengths and cutting them in half. Then remember, with a horizontal line, vertical lines are perpendicular, so I'm just going to trace the vertical line through the red dot. And remember, with vertical lines, horizontal lines are perpendicular, so I'm going to trace the horizontal line through that red dot. And I can see where they cross. I can see it's on that hypotenuse, which should make sense because this is a right triangle. And now I just need the ordered pair. If you actually notice, you can get that ordered pair from looking where these red lines cross those x and y axes. So this vertical crosses at 2, so my x is 2, and this horizontal crosses at 3, so my y is 3. So I get my ordered pair. All right, and I think that is it. Well, that was the beginning of lesson 5.3 for geometry, using perpendicular bisectors to find the circumcenter.